All right, so we're finishing up notes 5.4. So the last thing we had done was example, the only things we have left are example 1, example 2, and example 3. So example 1, the first thing we need to acknowledge is that this is factor form, right? How do I know it's in factor form? Because, I mean, you can see that you're multiplying those factors, x plus 1, x minus 1, and then x minus 3 squared, okay? So for these examples, we need to make sure we know when is it in factor form and then when is it in standard form. Now, to draw a sketch, we need, we really just need to find our graph comparison and then the x-intercepts and the multiplicity. We just need to find all those little key features from each one, okay? So the first thing we need to do is that we need to find our graph comparison. So in order to find that, we need to know the degree and the leading coefficient. So the degree can be found from factor form. We did this on the chart above on numbers 3 and 4. We're going to grab our factor form. And then we have to make sure that each one has an exponent of 1. This one has an exponent of 2, so then we're going to expand it out. So x plus 1, x minus 1, x minus 3, x minus 3. Okay, so there we have our factors. Now, remember, inside of each factor, it has to be written from greatest degree to lowest, right? So luckily, they all have the highest degree, and each factor is a degree of 1. So we have power of 1 and then no power, so we're good. Then we're going to look at each one. Each one has a coefficient of 1. So we have 1, 2, 3, 4. These 4 things is what we're going to multiply. So 1x times 1x times 1x times 1x. So you're going to end up with 1x to the power of 4. This right here is what would be your leading term. So now I know the degree is going to be 4, and then the leading coefficient sign is going to be positive because I included the coefficients when I was multiplying. Now that we know this, then we know that this is even. So because it's even, we're going to use this with the leading the leading coefficient sign for our comparison, right? Remember, we know it's even degree and the leading coefficient is positive. So which graph comparison can we compare it to? Hopefully you thought quadratic. Why is that? Because quadratics have x squared, which is also even, right? And it's going up because positive, right? So it has to go up. So the only thing we really need is we need the end behavior. Remember, this middle part is going to be completely different, and it doesn't really matter. When we're doing our graph comparison, it's because I want to know what the end behavior is going to be. So over here in this bottom corner, we can go on ahead and draw our graph, right? We're going to draw a little sketch of what this would look like. And the first thing I'm going to put on here is my end behavior, which is going to be up and then up. So I know, right? So if I had a multiple choice test, because I've already figured out the degree of the polynomial, I would know that my graph would have to have 2 arrows going up. Okay, now that we found the end behavior, the next thing to find is going to be the x-intercepts, right? So when it's in factor form, right? Remember, we have factor form, right? When it's in factor form, the x-intercepts are really easy to find. All we have to do is use zero product property. Okay, so what are we going to do? We're going to grab all of our factors. So we have x plus 1 equals 0. We have x minus 1 equals 0. And then it's up to you if you want to put x minus 3 squared equals 0. Regardless, I'm going to go on ahead and write both of them out because I want to emphasize a point. So I'm just going to do each factor that I have, right? And then zero product property means you're going to solve for x. So we take away 1 from both sides. So x equals -1. There's 1. Add 1, add 1. So then x equals 1. Add 3, add 3. I forgot the 0 there. So x equals 3. And then add 3, add 3. And then x equals 3. So what do we notice? We notice that we have an x-intercept at -1, an x-intercept at 1. And then you should hopefully notice that we have an x-intercept that duplicates. That's a duplicate, right? So we know this is going to cross because it's 1. It has a multiplicity of 1, right? So if we come back over here, there's that multiplicity of 1. If you look at the original at the top, multiplicity of 1. This one has a multiplicity of 2, which makes sense why we have x minus 3 2 times. So this is going to cross multiplicity of 1. This one duplicates twice, which means it's even, right? Which means it's going to bounce. It's a duplicate even times, right? So if it were a duplicate of odd times, then it would cross, but it would lay down and so forth. So this one is duplicate even, so bounce. So now we're going to use our x-intercepts and we're going to graph them. So we're going to put -1 around here. I'm going to put +1 here, and then let's put +3 about there. So remember, I'm going to put C's and B's. So at -1, we're going to cross. I'm going to put a C. At 1, we're also crossing. And then at 3, we're bouncing. So I'm going to put a B right there. Once you have your x-intercepts, the next thing to do is just to follow through with what's going to happen at each x-intercept as you connect them to your arrows. So right here in purple, I started connecting to that first arrow on the left, and it's right here, oops, right? At that -1, we're going to cross. So I know I'm going to cross. And then the next x-intercept would be at 1. And it says I have to cross again, which means at some point, this graph is going to have to turn to cross through at 1. And then at 3, there's another x-intercept, but it says B. It's going to have to bounce. So at one point, this polynomial is going to have to turn around, hit the 3 and bounce off of it, and then connect to your arrow. So that would be the sketch of this polynomial. Okay, next one. Example 2. Sketch the graph of f of x equals x cubed plus 4x squared plus 4x. So the first thing we're going to write is we're going to identify what form it is, and the form of this one is standard form. Right? So we have standard form. Now, when it's in standard form, it's really nice because we can find the leading term. The leading term is right here, right? And I know this is the leading term because it has the highest power, right? The highest degree. So using that, I can actually identify the degree and the leading coefficient without really having to do any work the way we did in example 1. So the degree here would be a 3, and then the leading coefficient sign is going to be positive. Okay, so we know that this is an odd, and we have a positive leading sign. So you can use your chart at the top of in your notes, or you can think, okay, so the degree is odd. So what function is that? Which function are we going to use for comparison? Well, the function that we would use for comparison, because it's odd degree and positive coefficient, right, would be linear function, y equals x, because it has a power of 1, which is odd. Let me check something. Yeah, right. And then this power right here is odd, which is the same as what our polynomial has. So we're going to want this end behavior. So on the left side, it's going to decrease, and on the right side, it will increase. So I'm going to, for this example, I'm going to go on ahead and put my chart for my sketch on this side, because the right side we're going to be using for something else. Okay. And what do I know so far? I know that my end behavior on the left side is going to go down. And on the right side, it's going to go up. So as you can see, I have went on ahead and put those arrows. And obviously, if I need to move them or something, I will, okay? Because it depends on where your x-intercepts are. So now that I have my end behavior, I need to find out what's going to happen in the middle. So in order to find that, I need to go find the x-intercepts. Now, this is in standard form, which means in order to find the x-intercepts, we're going to have to convert to factor form. And how do we do that? By factoring or using X method. If you are in my room right now, you can see the poster is on the board and you can use that to help you with this, okay? So we have our equation. So x cubed plus 4x squared plus 4x. So step one, is it in standard form? Well, yes, it is. Step two, we're going to factor out the greatest common factor, right? So the greatest common factor here, what do we notice they all have? Hopefully you see that we have x cubed plus 4x squared plus 4x. They all have an x in common. So I need to factor out an x. So what am I going to be left with on the inside? We're going to have x squared plus 4x plus 4. Now that we have this, we can do step 3, which is identify A, B, and C. So A would be 1, B would be 4, and C would be 4. Using these numbers, we're going to do step 4, which is set up your X, right? Your little diamond thing. The top is always A times C, which is 4, and the bottom is going to be B, which is 4. So what two numbers can we multiply to 4, but when you add them together is also 4? So the answer would be 2. Let me do a different color. 2. Okay. All right. So there's your two numbers. So once we find these two numbers, we can go on ahead and write it in factor form. So we're going to have x plus 2 and then x plus 2. After this step, we're going to divide and then simplify. Don't forget to bring down this x that we pulled out earlier. Now, but here a is 1, right? So is a 1 actually going to change anything if we divide by 1? No. So your factor form is as what we wrote, x times x plus 2 times x plus 2. That would be your answer. Okay. Now that it's in factor form, are we done? No. We know that factor form is this, right? So now we can use zero product property and apply it to factor form. So I'm going to grab the first factor, x equals 0. Then I'm going to grab the second one, x plus 2 equals 0. And I'm going to grab the third one, x plus 2 equals 0. I would like to take this opportunity and mention that this is the same as x times x plus 2 squared. So hopefully you will see that that squared means something, right? Okay, so let's find our x-intercept. So x equals 0, that's my first one. I'm good to go. The next one, I'm going to subtract 2 from both sides. X equals -2. Same thing on the next one, subtract 2 from both sides. X equals -2. So what do we notice? We notice that we have one x-intercept at 0. So we know it's going to cross because it has a multiplicity of 1. Do y'all see that? It has a multiplicity of 1. And then remember, notice that this one is really written twice, right? X plus 2 squared. And what do you see? You see that you're going to have, you see x equals -2 duplicated 2 times, an even number of times, right? So it's an even duplicate. And remember, that's important because you can have an odd duplicate, right? That just means multiplicity. So what are we going to do here? We're going to bounce. So I know that at x equals 0, I'm going to have that x-intercept right there, and it's going to cross. And I'm going to have an even duplicate bounce at -2. So -2, let's make that about here. And then it's going to bounce here. Okay, so then now, I just need to connect what is happening at my x-intercepts with my arrows, my end behavior. So my arrows down here on the left, it's gonna go up to the -2 and it's gonna bounce. And then at the next x-intercept, which is at 0, we can see that it's gonna cross. So that means that this has to turn at some point and then cross through here and then connect to the arrow. So that arrow wasn't the prettiest, right? But we get the point, okay? So let me leave that in pink. So there's your arrow, but it still goes up. And then there you go. That is a sketch of your polynomial in standard form. All right, so now if you're watching this video on your own time, you should probably pause it and go on ahead and do the U-try on your own. If someone is in my room playing this video for you, then pause it, give them about 2 minutes to get started, see how they feel. If they need more time, you can give them another 2 minutes. If they're just completely stuck, go on ahead and play the video because I'm gonna go over it, okay? So pause the video now. Okay, I don't know if they paused it or not, or if you paused it or not, but if you're just gonna keep going, here we go. Okay, so for this U-try, right, remember, well, what were we given? We're given standard form. So I already know that I can get the degree of the polynomial and the leading coefficient automatically without doing any work. But what am I gonna have to do work for? The x-intercepts, okay? So let's go on ahead and start. This is my leader, right? So we know that we have a degree of 3, and then the leading coefficient sign is going to be a negative this time. Oh, when I printed off y'all's notes left out the negative. So please make sure that you put this negative right here in front of the 2 in your notes. That mine does and yours does not. So make sure that's there. So the leading coefficient sign is a negative, not a positive, okay? Now, after finding my degree and leading coefficient sign, I can figure out the end behavior, right? So my end behavior is found by doing a graph comparison. Okay, so we have an odd, this is odd degree and a negative coefficient. So what does that mean? This is going to mimic a negative linear function, right? Y equals X, because this is also odd, but we want that negative because that's what we're using to get our end behavior. So on the left, we're going to go up, and on the right, we're going to go down. So we're going to draw our graph, our sketch on this side also, because we're going to have to use the right side for factoring and to find our x-intercepts. So right here, I know that on the left, I'm going to have to go up on the left because we're going to mimic. Let me slant it a little bit. And then on the right, we're going to go down. Okay. So we have our end behavior. So now what we need to do is find our x-intercepts and figure out what's happening at each one. So we're finding our roots and the multiplicity of each one. So we're going to have the x-intercepts. And remember, we're going to have to convert to factor form. So we have negative 2x cubed minus 16x squared plus 18x, and it's in standard form, obviously. So your greatest common factor, hopefully you noticed, was a negative 2x, because your leader also can't be negative, right? So we're going to factor out that negative 2 from everywhere along with the x. So we're going to factor out a negative 2x. What are we left with on the inside? We're going to be left with x squared, minus negative 16 divided by negative 2 is a positive 8x. X squared divided by x is x. And then 18 divided by negative 2 is a negative 9. And then these x's, x divided by x is just 1. So they cancel out. Okay, so now we factored out that negative 2x. So now we have a is 1, b would be 8, and c was negative 9. factor form or your X method. So at the top, we would have had a -9 and at the bottom a +8. What two numbers multiply to -9 and add up to 8? That would be a -1 and a +9. So now that we have these two numbers, these numbers are going to go X minus 1, X plus 9 into our little factor form. And then don't forget to bring down this -2x that we factored out earlier. Now we divide by a, but a is 1 here, right? So is the 1 going to change anything? No. So our factor form is -2x, x minus 1, x plus 9. So then what do we do now to find our x-intercepts? We're going to apply zero product property. So -2x equals 0, x minus 1 equals 0, and then x plus 9 equals 0. Hopefully right now you're noticing something, and that's that no factors are duplicated, right? They each have, you see each one once. So that should already kind of be telling you what's going to happen at each x-intercept. So here we're going to divide by -2. So x equals 0 because 0 divided by a number is on, which means it's 0. Then we have x minus 1. So we're going to add 1 to both sides, x equals 1, and then subtract 9 to both sides. So x equals -9. So you have 3 x-intercepts at 0, 1, and -9. And we know they're all crossing because they all have a multiplicity of 1. Okay, so let's go do that sketch. So let's put -9 about here. Then we're going to have 0 here in the middle at the origin, and then 1 can be about here. Okay, so now that we put all of our x-intercepts on our graph, we know that they're going to cross, not bounce, just cross. So I'm going to start on the left side. I'm going to grab my arrow, and then I need to cross at -9, and I'm going to cross at 0. So I know I'm going to have to come back up and cross, and then I need to cross at 1. So I need to turn and then come back and cross at 1 and then connect at the arrow. So that is a rough sketch of what this polynomial would look like. Okay, that's it. Go on ahead and do your assignment. Some of you, it was a paper assignment at the front, and then there's also a quizzes assignment on Canvas. Go on ahead and get that done. Thank you. See y'all next time. Bye.